Hello, and thank you for joining us. My name is Peter Carfuzzi, an aerospace sophomore here at WPI, and with the audiovisual live streaming practicum. With me here today, I have David Fournette, a robotics senior and one of the creators of the Koalby MQP. And today we'll be learning a bit about Koalby, his capabilities, what his future prospects are, his creation, some of the inspiration behind Koalby. David, how are you today? Thank you for joining us.
Yeah, I'm doing pretty good. It's been a good day. Ready to show a little bit what Koalby does.
Great. So tell me, when I look at Koalby, I see some pop cultural influence. And I'm wondering if in the design of Koalby there was any pop cultural inspiration. And I'm talking WALL-E, I'm talking Terminator, I'm talking Real Steel, iRobot. Was there any inspiration in that sense from pop culture?
Yeah, so kind of yes and no. Koalby is mainly based off of a 2012 open source project from France called the Poppy project. And those original creators did take some pop culture reference, I think. They had a head design, their latest head design, which was called the Eve head. So Eve from WALL-E. And it kind of had the same shape, look as Eve's head from the movie. And then also the eye animations were very similar to Eve from that movie. Our group in particular based more around other humanoid robots. However, we did use a similar idea of trying to find personable, good interactive eye animations based off of the sort of pop culture references. So.
Yeah, and we also know here at WPI we have WPI's Atlas robot and a few other humanoid robots in creation today, such as SoftBank Robotics Pepper. When I look at the structural frame of Koalby here, I can't help but notice also some similarities with the Atlas robot. And I'm wondering if the Atlas robot helped you at all in your project creation and inspiration.
Yeah, so we did look at a number of different humanoid robots through literature review and things like that. Like I said, Koalby is based originally on Poppy. So our team did a lot of mechanical redesign of the original open source Poppy design to lessen the cost of the design and to modify it for new motors, things like that. Of course, all humanoid robots are going to have some similarities. This is a 25 degree of freedom robot, meaning it has 25 motors. If we have actuated hands, if you add those, it becomes 27. But similarly, other humanoid robots will have a similar number of degrees of freedom, etc., to mimic our sort of human joints. So.
And on the topic of these degrees of freedom, can you go into what the engineering design process looked like for Koalby? I'm talking from initial design phases to prototyping, to testing, to reviewing, and even to communication. What did that process look like for Koalby?
Yeah, so we were lucky to have a really good team dynamic. So we split up our tasks based on our strengths and weaknesses in certain areas. Koalby is a fully 3D printed humanoid robot. We use DLP resin printing. So basically everything that is blue on Koalby is 3D printed in some manner or form. And basically our design process looked like taking the Poppy project, that original open source project, reviewing it, trying to figure out what worked in it, what didn't, and then started work on how we could first reduce the cost. So that original Poppy project, if you were to get all the parts yourself, so source all the parts, would cost about $7,000. We've reduced the cost to Koalby now to about $4,000, so a $3,000 price difference basically, which is pretty good. The main way we did that was replacing Dynamixel motors for Hercule X motors, which is just a different brand of motor. They're cheaper but have the same sort of torque specifications, and then we redesigned parts to fit those motors. Then we also wanted Koalby to be battery powered, which originally Poppy was a wall tethered robot, I mean need to plug into a wall for power. But we wanted full battery capabilities and full untethered capabilities. So we've basically extended Koalby's shins and slapped batteries in there. And then he also has one in his head, which powers his screen and other motors. Unfortunately, that head battery is deactivated for today.
Mm-hmm.
But yeah,
essentially made him mobile.
Yeah, exactly.
To join us in the studio today.
And then Koalby on a code base side, we referenced that original Poppy library, but it was really complex, very, very, very poorly documented, things like that. So we went ahead and scrapped it and used it as general reference, but then made our own code base for Koalby, which is a lot simpler, and has some cool functionalities. So, yeah.
And speaking on the hardware and the software, how many iterations did Koalby require?
Yeah, so technically this is version 1 in a way. However, there's a lot of iterations for parts of Koalby, right?
Right.
So, for example, we had a very early test version that was just the arms of the robot, just bolted onto a piece of wood, right? And that was for testing basically motors, testing printed parts, testing weight and lift like specifications. What could Koalby lift with his arm? The answer is 150 grams, so not much. But basically, a bunch of those test versions. So a lot of the different parts, like individual parts, went through lots of different versions. So, for example, the shins have gone through probably around anywhere from 5 to 15 versions as we've iterated them up. In addition, we have different prints of different materials. We started off in FDM printing, so that's the sort of standard hot plastic version of 3D printing.
Right.
And then we moved to resin printing, which is a liquid resin that you cure into a hard plastic using UV light. And then we swapped to a different type of resin to get better material properties and things like that. So individual parts, many iterations, the entire robot as a whole, this is technically version 1.
Version 1. So on all these iterations, what were some of the challenge or lack of specifications met that required you to go into all of these iterations?
Yeah, so there were 2 areas I'd say that were pretty challenging. One was on a hardware side, basically trying to find the right material properties for the prints. So we started off with FDM, like I said, but Koalby has a lot of holes in him, which are all weight reducing, basically. Right. Which those are great for reducing weight, but with FDM printing, you can't really get the resolution to make those parts well. So that's why we swapped to resin printing. And then in resin printing, one of the great things about it is that you can really mess around with material properties. So we ended up swapping to a 2-to-1 ratio mix of 2 similar resins. One which is a hard tough resin, and the other one which is a high temp rigid resin. The hard tough basically means if I drop it on the ground, it won't break. And the rigid means it won't bend. So hard tough's a little flexible. So the reason we did the mix of those is because Koalby needs to be able to undergo pressures if he were to hit something too hard, things like that. But also we need the parts to not flex, right? If he's pulling his whole arm, you don't want the shoulder to bend. So that was one area, and then the code base was really, really the most difficult part, probably, because we basically redid the entire code base from scratch. But first we had to understand the Poppy library, which, like I said, was very poorly documented. One of their comments in that library was, "Ask Pierre about this." I don't know a Pierre, so.
Which isn't too helpful.
No, not very. So that was a really big challenge, was just trying to figure that out and really get a code base that worked. Eventually we got our control method. It's called a primitive manager, which basically means that we can run a number of different motion controllers and then simultaneously through multi-threading, and then merge them all together, and one output goes to the robot. So basically, if it takes a step forward but also wants to balance, those two will merge and it will do both at the same time.
Yeah.
So yeah.
We know the concept of weight reduction is similar to the cavities in the bone, there to offer weight reduction. But looking at Koalby here, how did you determine where to include the structural frames to incorporate this weight reduction?
Yeah, so the original open source design kind of had a lot of that already done for us. One of the interesting things about Koalby with the sort of resin printing is that we are able to play around with weight as well through that. So you can kind of get a less dense resin, a more dense resin, things like that. So you could really play around with Koalby's weight there. And then in addition, some of the other, you kind of mentioned like cavities and bones and things like that. Koalby is a scaled down humanoid robot, so it has the proportions of an average adult human, right? So one of the cool things about Koalby is like kinematic study. If you notice, his thighs are kind of planed in at an angle, which is because your thigh bones, are also planed in at an angle. So sort of like changing slight things about his body format can teach us more about humans' motion, right? So what's the thigh angle and how does that affect your walking cycle and things like that.
So what human motion is Koalby capable of? What are his capabilities as a whole as well?
So Koalby is capable of all sorts of motions. Right now we have sort of a replay record functionality, which is an animation-based thing. So we have a number of them. I can show you some of those now. I do have to type into the computer for these. But we basically have a number of recorded motions. So you basically pose Koalby in different spots and can then play those back. So here he'll initialize, so that's him just sort of standing. He's currently on a stand right now just for stability. So I will play a pose here. We'll do Macarena, and he'll do it 5 times. So he'll be a little loud. That's how motors are. But basically, the way this works is we pose him at different spots, hit enter, and record it, and then tell him to play back those poses at different timings, basically. His neck is going to kind of tip down here because his neck motor is currently deactivated. But yeah, so he'll basically just go through this Macarena pose that we've given him, however many times I've told him to. And he has a number of these. He can wave, he can shake hands, he can do the sprinkler, he can do the disco, mostly dances, but all sorts of things. So he's finished it now 5 times here. So he has all sorts of motions though. He has full body capability. Right now though, his abdomen and neck motors are deactivated as a team member is currently working on some Wi-Fi capabilities for him and has taken that board. So.
Right, so as we know, you are a current senior in robotics engineering. Once you graduate, you might not have the opportunity to work on him, develop him anymore. Career might take hold, family, things of that sort. But if you had the time to continue developing Koalby and the funding to do so, where might its potential and your ideas take you? Yeah,
so right now this MQP is planned to stem into 3 more MQPs. So they will be continuing our work a little bit. Mainly, Koalby has full body functionality, but does not have any self-balancing algorithms, and technically has very little to no sensing of his outside world, right? He can know where his joints are through encoding, but he doesn't know what's around him. So basically what their groups are going to focus on are self-balancing. So they'll likely be putting about 8 force sensors in each foot, and then inertial measurement units, so tip and accelerations, things like that, in his chest and in his abdomen, and then a camera in his head for vision. And Koalby will use all that to figure out how to balance himself. And then in addition to that, another group is going to probably be looking at vision and motion replication. So looking at a person and then mimicking what they do. So doing whatever they do. You dance, Koalby will dance, right? And then the last one will be a mechanical MQP focused on optimizing parts. So lowest weight, highest strength, basically, as well as reducing fasteners. So Koalby right now has about 500 screws in him. So trying to get a lot of those screws out and replace them with like clip connect joints and things like that. In addition, personally, I'm thinking about taking this design and scaling it down to about 1 foot tall, and then replacing a lot of the expensive motors, which is where most of that price comes from, with really cheap hobbyist motors, trying to get Koalby somewhere around $200 to $300 instead of $4,000, right? That way, with a small grant, a school or something like that, could feasibly, get the design for Koalby and then use it as an educational model.
So as we know, 3D resin printing is much more respected with respect to just FDM printing, much more expensive with respect to FDM printing. How do you balance sort of the expenses going through the iterations with the improvements in the design of Koalby?
Yeah, so resin printing can be more expensive than FDM, but it kind of depends as to what you do, right? So if I use a carbon fiber filament for FDM printing, it's going to be more expensive. Whereas if I use a really cheap resin, it'll be less expensive than that. But it's kind of this balance. Resin printing is a lot more reliable, I've found, and allows you to get a lot higher resolution, which Koalby has a lot of very small screw holes right now. And to get that kind of resolution... Oh, hi there, bud. He wanted to say hello. I'm going to shut him down for now. But anyways, to get that resolution, you basically have to use resin printing. So that's one of the reasons we swapped. Right now, every part on Koalby completely printed one time is about $70. So not very bad. It's pretty on par with FDM in that regard, because again, with FDM, you might have a lot of print failures, or parts might not come out right, or you might not get the correct pocketing, things like that. In addition, resin printers aren't that expensive. The one that we use currently, the printer itself, costs about $250. So, you know, with a grant or something like that, if the robot costs about $300, the printer costs about $300, then for a $600 grant, then you could fully manufacture and build the entire robot yourself. So
I see. Yeah. So what really comprised the bulk of the expenses in designing Koalby for the inventors out there?
Yeah, so the bulk of the expenses is definitely the motors. Like I said, Koalby has 25 motors on them, and our main cost reduction was through those motors. So originally, the Poppy project used only Dynamixel motors, which are smart motors, smart embedded motors. And for example, Koalby has 4 of them on him right now. Each motor costs about $400 to $500. So those are where a lot of the expense comes in. I think the total of those 4 motors is somewhere around 2,300. And then the other 19 motors, which we have swapped down, they used to be Dynamixel motors, but a different kind of Dynamixel. They used to cost about $300. We swapped them for Hercules, which have about the same functionality, but cost about $130. So that's a big chop to the price, and all 19 of those Hercule motors cost somewhere around $1,500. So a pretty hefty chop there from the Dynamixels, but that's definitely where the price comes in. If you were to swap all of the motors on the robot for, you know, motors that cost somewhere around like $30 to $20, like most hobbyist servos do, you could chop the robot's price significantly down. So
right.
Yeah.
So with that price tag, obviously you don't want anything to go wrong.
Yeah.
But I have heard from a friend of yours that there has been some things gone wrong. Can you go into a little more of those issues experienced there and how you sort of overcame them and continued development on Koalby?
Totally. So, yeah, of course, anytime you're in development, there are bound to be some issues. We have some very funny videos of Koalby twisting and contorting his body and then breaking a hip or something. So right now, basically, Koalby is meant to be a safe interaction robot, right? So the Hercule X motors have a nice functionality where basically if they experience too much torque or too much force on them, they'll automatically shut down, which is good. We want that. Because basically what that means is that it keeps Koalby safe and it keeps anyone interacting with Koalby safe. I like to make the joke that was sort of like, you mentioned Terminator earlier, which is if you got in a fight with a Terminator, you'd probably lose. If you got in a fight with Koalby, you would 100% win. If Koalby feels too much force, which you can pretty easily give, then he'll just shut down. He'll shut down that motor. The rest of him will keep running, but that singular motor will shut down. And that's just for safety reasons. It keeps all his parts safe, and it keeps you safe. The main problems we've had right now are those 4 Dynamixel motors. We're currently adding that functionality, but they don't have them. So for example, the thigh motors here don't have that, which is all in test right now. That's why we don't use it for demo, is because we don't have that on the Dynamixels right now. But basically, those are the ones that really cause the issues because they're also very torquey. They put out a lot of force. So for example, a little while back, we had Koalby sort of forget what he was doing and twist his pelvis pretty hard, and he broke one of his pelvis prints. But the good thing is that we've made sure that all of the prints, if a motor is going to be torquing them, that it will break in a specific spot on the print rather than the motor, right? We don't want to destroy a motor because they cost about $400. We can reprint a $10 part. That's no problem. But so we've kind of tried to put some of those design ideas in to basically keep the expensive parts of Koalby safe, as well as to keep the people interacting with Koalby safe, which is why those heftier motors aren't used for demo and are only used for testing, basically. So.
Speaking of that human-robot interaction, where do you hope that will take you?
Yeah, so at the Touch Tomorrow event, which is an event hosted by WPI, we got to see Koalby interact with all sorts of people, adults, kids, basically full age range. So we got to have adults come up and ask us like, oh, what are your resin printing specs? What motors are you using? Things like that, right? And then kids would come up and dance with the robot. We had lots of kids shaking hands. So Koalby has a handshake capability where basically he puts his arm out, and then when you take his hand, he'll shake your hand. So lots of kids did that, and we got to see basically a really good example of Koalby interacting with people. He kind of sits a lot of times with humanoid robots. There's sort of this uncanny valley. Luckily, though, Koalby is not quite human enough, I think, to fit into that creepy area. So he's personable, especially with his eyes turned on. He's pretty cute and easy to go up to and sort of interact with, which we found he sort of fulfills that HRI, human-robot interaction role very well in practice. So
definitely puts out a positive face out there
Yeah.
for all the humanoid robots.
Yep.
David, it's been a pleasure having you on our program. Thank you to all the viewers who joined us tonight. If you'd like to learn more about the Koalby MQP, feel free to visit David Fornet's website and check out his YouTube channel to see some of the dancing and interactions. Thank you, everyone.